Acha. So binary search. So in binary search over the GitHub, ZAK on web, algorithms A2, binary search variations, and I have given the binary search's definition. Binary search is a search algorithm that is used to efficiently locate a target value within a sorted array. The algorithm works by repeatedly dividing the search interval in half, comparing the middle element of the interval to the target value, and narrowing down the search space until the target is found on the interval becomes empty, or the interval becomes empty. So here's an algorithm to implement binary search. Initializes two pointer left and right to the first and the last indices of the array. One is pointing to the lower limit, the other one is pointing to the upper limit. While the left pointer is less than or equal to the right pointer, means that every time we find the middle, either the value will be found, or eventually what will happen, that finding the formula that we use will make the lower count bigger than the upper count. Either the upper count will come down and become less than the lower count, or lower count will go up and becomes higher than the upper count. So while the left is lower count, right is upper count. So calculate the middle index, mid, as the average of left and right integer division, means left plus right diff 2 is the middle. Compare the middle element of the array at the index with the target value. If the middle is equal to the target, return middle. If the middle is less than the target, the left pointer point to the middle plus 1. So what basically left pointer is, since it is the lower bound, so it will come up. So this way we have gotten rid of half of the elements of the array. And if the middle element is greater than the target, in that case, upper bound or the right will come down, middle -1. If the target is not found, the system will return -1. How the system would know that target is not found? When the upper will become lesser than the lower count. Binary search is an efficient search algorithm that can be used to locate and target values within a sorted array. So this is the prerequisite for binary search, that the array should be sorted. Otherwise, it would not work. However, there are certain conditions that must be met for binary search to be effective. The array must be sorted in ascending or descending order. The search is typically performed on an array or list data structure. And mind it, in your syllabus in A levels, it is mostly ascending order. The elements of the array must be comparable. We can apply less than or greater than operators. Another thing which I forgot to put up here is that all the elements should be unique. All right, for your syllabus, all the elements should be unique. So since I was writing in general way, so I have not put it here, I forgot, but all the elements should be unique. The performance of the binary search can vary depending on the number of data items being searched. As the number of items increases, the time taken to perform the binary search generally increases logarithmically. Logarithmically means you would have so many values, but after each comparison, half of the array is gone. So this means that the time taken to search 100 items is roughly double the time taken to search 10 items. You see, it goes logarithmically. Okay, and the time taken to search 1000 items is roughly double the time taken of 1000 items. Binary search, it is not linear progress. All right, so it is not linear progress. More elements are searched in lesser time, and if you compare, you would know. So logarithmically. Binary search is therefore very efficient search algorithm for large data sets. As I just said that in insertion sort video, that insertion sort is not good for many values. There is no comparison between binary search and insertion sort, but I'm telling you that few of the algorithms behave differently with more or less data values. Okay, I can compare binary search with linear search. With linear search, since it is a linear progress, so more items means more time, and that time is not logarithmic. Means, like I said just here, that this means that the time taken to search for 100 items is roughly the double time taken for 10 times. Okay, in linear search, double time will be for 20 items, not 100 items. Okay, this is what I meant. And the time taken for 1000 items is roughly the double of 100. So binary search is therefore a very efficient algorithm for large data sets, as the search time grows very slowly compared to the size of the data set. Means data set grows phenomenally, but the time to search the data set does not go that way. It grows slowly. Okay, so I worked out few variations. Your syllabus just has one variation, not more than those. Okay, so hold on. Just a minute. So basics binary search. Questions asked in A-level belong to this implementation. So we are going to cover basic binary search. This is the standard version of algorithm which searches for a target within a sorted array by repeatedly dividing interval in half. All right, interval means the difference between the first and the last element. It compares the middle element of the interval with the target value, and if they are equal, the search is successful. Otherwise, the search continues in either the left or the right half of the interval, depending on whether the target is smaller or larger than the middle element. Okay, so let's program it. If you like to check for the variations, you can go in advanced implementation, and over here, I have given all these variations, their explanations, Java code, pseudocode, Python code, VB code. Okay, so we are basically just going for basic implementation of it. All right, so let's see how. So code for basic binary search. Questions in A-level will be asked for this. I have copied it so that you could refer to it. The whole text. All right, so this is doc string. Let us start. So let's first see how is pseudocode working about it. So this is iterative binary search. In basic, we would have iterative form and as well as recursive form. So in iterative form, you are sending an array and the target value. So it is basically making left 0 as the list always start from the 0 index, and then right will be, or the highest value will be the number of elements minus 1. Okay, so while the left is less than or equal to right, we will keep finding the value. We will calculate the mid, left plus right mod 2. So this would be the middle. We check at the middle. If the target is at the middle, we return the middle. Else, if the value at the middle is less than the target, we update the left. Otherwise, we update the right. Okay, so that is how it works. So let's do it in basically function form. Okay, so return the index of the target if it is found, else return -1. So left is 0. Okay, exactly the same code. Right is the length of the array -1, while left is less than or equal to right. So calculate the -1. So this basically, this is a mod in Python. Is floor division or integer division. Okay. Okay. Now, if the value of the target that we have to find, if it is at the middle, we return the target. Otherwise, we update the right or the left. Okay. So left is lower bound. Right is the upper bound. Okay. So this is iterative binary search. All right. Iterative means we have a loop that is working on every element, and the system is not calling basically itself. The function is not calling itself. So let's write a recursive binary search. Binary search recursive. In this case, we have to take care of upper and lower bound as well. So every time we are going to write this code, we will actually be sending the array, the target, and the left wala and the right wala as well. Because every time we update left and right, we call the function again. Okay, so if it is found at the middle, we return the middle. If we update basically the right, so we call this function once again. Recursion is what? Recursion is basically calling itself. When a function is calling itself, it is recursion. When a subroutine is calling itself, it is recursion. So it is calling itself, but with the updated upper bound. Okay, and similarly, if it is not less than, the target is not less than the middle. If it is greater than the middle, then in that case, we are actually updating the lower bound. So it goes on. So let's just try. Search array is equal to, let's put more values to it. Okay, so this is our search array. This is our main program now. All right, so let's say target, let's take target as input. Integer of input, enter the target value. Okay, value to search for. Okay, so first iterative binary search, and then we have recursive binary search. Okay, so when we are calling iterative binary search, all we have to do is to send the array and the target. But if it is a recursive binary search, in that case, we have to send the array, the target, the lower bound, the upper bound, and all. So lower bound is always 0, upper bound is the length of the array minus 1. So that is how it works. This is very simple. Let's save it. सर लेंथ -1 क्यों की है? लेंथ -1 इसलिए की बेटा कि लेंथ तो एक्चुअल नंबर्स में आती है ना, जबकि हमारे पास अपर बाउंड -1 होता है. मींस अगर if there are 5 items, so those are 0 1 2 3 4. Length is 5. So length -1 means 4 is basically the upper bound. Get the idea? So this is the first item, but the index is 0. This is the last item, but the index is 12. It's not 13, and actually the length is 13. Where the lowest item is 0 index and the highest index is 12, not 13. 0 to 12 is 13. Actual number is length. Length is always an actual number, which is 13. Get the idea? Understood now? Okay, good. So let's run this code and see if it is working properly. Enter the value to search for 5. They both are saying it is at the location 4. So see, 0 1 2 3 4. So it is at location 4. So it is being found. Now let's run it again and see. Let's find a value which is not there. 15. They both are basically giving what? -1. Okay. So this is your binary search. So binary search is good. All right.